Now we're going to start looking at solving linear equations. First thing we need to cover is some vocabulary again, and the first one is equation, and that's just a statement in which two expressions are equal. Now the key to having an equation is that there is always an equal sign. A linear equation is an equation in one variable, and it can be written as ax equals b. Now the key to be linear is that the exponent of the variable is 1 and only 1. So even though we don't see an exponent here, when there's not an exponent present, it's assumed to be a 1. Now if this was x squared, we would not have linear. That's a different equation. And a solution is a number that when you substitute it in for the variable, it makes your equation true. And equivalent is when two equations are equivalent if they have the same solution set. So 2x plus 10x equals 12x, those would be equivalent expressions, because no matter what I put in for this value of x, they will still be equal. Okay, now to get equivalent equations, we can do a lot of different things. And these are all the properties that we're going to be using in order to find solutions. Now our addition property of equality says that we can add the same number to both sides of the equation. If you think of this as a balance scale, and we have both sides being equal to each other right now, so they're balanced. Well, let's say that I were to add 5 more boxes to this left side. In order to keep it balanced, I would have to add 5 more boxes to the right side. And now when we do this addition property of equality, it's always on opposite sides of the equal sign. So if I add 5 to the left side of the equal sign, I have to add 5 to the other side of the equal sign. Same thing happens with subtraction. Instead of adding 5, maybe we're going to subtract 5 boxes from the left. Well, in order to keep my balance scale balanced, I would have to take those 5 boxes off of the right side also. So we can do it with addition or subtraction. Multiplication property of equality. Same type of deal. Let's say I want to double, so I want to multiply it by 2. I want to double the number of boxes on the left. If I want to keep my equality, I have to double the boxes on the right side also in order to maintain balance. And then division also works the exact same way. I can maybe take half of the boxes, so if I divide it by 2, I would have to divide the other side by 2 in order to keep that balance. So we have these properties, and what you have to remember is that they produce equivalent equations. And we have to do the same thing to the right side as we do to the left side. Okay, when we solve linear equations, our goal is to isolate the variable. Now when I use this word isolate, I mean to get it completely by itself, so it is all alone on one side of the equal sign. Now it doesn't matter if it's on the right side of the equal sign or on the left side. All that matters is that the variable is completely by itself. And in order to have this happen, we need to undo the order of operations. Now remember, our order of operations are please excuse my dear Aunt Sally, and that stands for parentheses or grouping symbols, exponents, multiply, divide, add, subtract. Think about when you get ready in the morning, you would put your socks on first, and then you would put your shoes on. Well, when you get home at night, when you undo that, you don't start with your socks again. You have to go backwards. You have to take your shoes off first because you're undoing what you did, and then you can take your socks off. Well, now when we are solving linear equations, we do that same thing. We undo these order of operations, so we have to work backwards. We have to undo addition, subtraction first, then undo multiplication and division, and undo the exponents. Sometimes you'll run into the situation where the variable is on both sides of an equal sign. So let's say we had 2x plus 5 was equal to x minus 8. If that's the case and you've got the same variable, but it's just on opposite side of the equal side, we need to move one of them so that they are on the same side and can be combined. And we would move them by using those properties over here, the addition property of equality, subtraction, multiplication, or division. And then in order to move items, we have to use their inverse operations. So if I wanted to move this x over to the left side here, since it is actually a positive x, I have to do the inverse of an addition, of a plus. I would have to minus x from both sides, because that's the inverse of addition. The reason we do that is because x minus x gives me a 0, and on this side I would have 2x minus x, which would give me an x, and then I still have that plus 5, and I would have 0 minus 8. What that does is that allows me to get all the x's to one side now, and I did that by using an inverse operation. Then I can simplify. Now I have to go through, since all my x's are one side, I need to get rid of any addition and subtraction on the side with the variable. We're not so concerned yet what's over here away from the variable. We are concerned with getting rid of the stuff over here by the variable. So since it's a plus 5, I have to do its inverse operation, which would be to minus 5. Well, I need to keep my balance scale equal, so since I minused 5 from the left side of my balance scale, I have to minus 5 from the right side of my balance scale. When I do that, I end up with x plus 0, because 5 minus 5 is 0, and then this negative 8 and negative 5 is a negative 13. Now I can simplify that. I don't have to write x plus 0. That turns out to be just an x, and I get x is equal to negative 13. Now I have the x completely isolated. It is totally by itself. I would have found my solution. My solution would have been negative 13. So the first thing I had to do was get my x's to the same side. Then I had to use these inverse operations to isolate my variable. Here's two problems that we're going to do together. The first one, I have 5y minus 17 equals 8. And I'm going to jot down my order of operations up here, just so I can have a visual reminder of them. And I want to check how many places my variable is. Well, my variable is only in one spot, so I don't have to worry about getting it all to one side, because it already is all on one side. So now I can go straight to undoing my order of operations. Now in this case, I have two things over here by my y variable. I have it being multiplied by 5 and a minus 17. Well, remember, when we undo our order of operations, we have to start from the bottom and undo that first. So I need to undo my addition and subtraction first. Well, that would be this minus 17. And to undo it, I use its inverse operation, so I have to add 17. Now I need to keep my scale balanced, so I have to add 17 to that side also. When I do that out, I have 5y. Negative 17 plus 17 gives me plus a 0. And then over here, I have 8 plus 17 gives me a 25. Well, I don't actually need to put this plus 0 as part of my equation because it doesn't change its value. So I actually have 5y equals 25. So I undid addition and subtraction. Now the only thing left over here by the y is this pesky 5. And since it's 5 times y, to undo the times 5, I have to do its inverse, which would be divide. So I need to divide both sides by 5 and divide by 5. On the left side, my 5's reduce to 1 over 1, so I'm left with 1y. And here I have 25 divided by 5, which turns out to be a nice whole number of 5. Not always going to happen that you get a nice whole number there. Now, you might be looking at this and say, you know what, my y is not isolated because there's still a 1 here. But a 1 we can essentially ignore. It's not necessary to have it written. So I really have y is equal to 5. Now what I want to do is I want to plug this back in and check it just to make sure it works. So when I put that 5 in here, now I can follow my order of operations. So 5 times 5 is 25. 25 minus 17 is 8, and that is what we needed to get. Okay, here's a second one. 7n plus 8 equals 3n minus 9. First thing I have to check is where are my variables. And I have my variables on two different sides of the equal sign. So what I need to do first is I need to move one of them. Now it doesn't matter if you move the 7n or if you move the 3n, that's entirely up to you. I'm going to move the 3n. And don't be confused by this minus sign right here, because that minus sign is part of the 9. It's not part of the 3n. So what you have to realize is that this 3n is a positive, it's a plus 3n. So in order to move it, I have to do its inverse, which is minus 3n and minus 3n. So on the left side, I'm left with 4n plus 8 equals, and then my 3n minus 3n turns out to be a 0, and then I still have this minus 9. Don't forget to bring down that minus sign because it is attached to the 9. It's like a negative 9. Now I've got my variables all on one side, so I need to get that variable isolated now. I have to undo my order of operations, so I first want to check, is there any addition and subtraction that I need to get rid of? And there is a plus 8, so I need to go through and I need to do its inverse, minus 8. I need to minus 8 on this side in order to keep it balanced. And then over here I still have my 4n. This positive 8 minus 8 gives me a 0. And over here, negative 9 minus 8 is a negative 17. Now I need to go and check, do I have multiplication division I need to undo? And I have multiplication here. I have 4 times n. Well, in order to get rid of the times, I need to divide. So I divide both sides by 4 and divide both sides by 4. Those reduce down to a 1 and a 1, so I'm just left with n is equal to. Now if you type this in on your calculator, you're going to get either a fraction or a decimal. You would get negative 4 and 1/4, or negative 4.25. I just want you to leave it as a reduced fraction. So 17 over 4 doesn't reduce, so I'm going to leave my answer as just negative 17 over 4.